In this section, we will discuss random numbers. What's generated by the computer are pseudo-random numbers. The fact that they are calculated shows that they are not truly random, because if you do the same calculation twice in a row, you'll get the same pseudo-random number. The Java math library provides a method that produces a floating point value in the range greater than or equal to 0, but less than 1.0. The number never equals 1. The math.random function produces that value, which can be used in various ways. Here I show the interval of its value. Notice the bracket. In interval notation, that means it includes that value of 0, comma, 1 paren. The paren says it's an open interval, which means it's up to but not including. My advice is memorize this interval and its implications. Remember, 0 is included, but 1 is not. So it's always going to be a value less than 1. It may be equal to 0. Some problems need random integer values. The math.random method does not produce integer values. An approach to this is to determine the range of integers needed and then multiply a random value by the maximum number needed, then add 1. There's a better formula that we'll discuss later, but for now, this works. Take, for example, rolling a 6-sided die. To simulate that, we need numbers in the range 1 through 6. Those represent the number of dots on the face of a die. We need to generate a random value and then multiply it by 6, then truncate. Because the interval is open on the one side, we will never return a value of 1, which means we will never, after this multiplication, have a value of 6. We'll always have a value in the range 0 to 5.9999 continuing, never 6. When we truncate, we chop off the fractional part. So we're going to have a number in the range 0 to 5. This is why I suggest you memorize that interval and its implications, because it's easy to think we're going to get a number in the range 0 to 6. Not true. Because 0 to 5 is a good interval, but it's not the right interval, we add 1 to shift the range from 0 to 5 to 1 to 6. Quick note here. In this section of the book, the problem that the author is solving is a subtraction practice program for young students. Generally, we don't teach the idea of negative numbers at too early of an age. The problem here is that if the number to be subtracted is greater than the first number, we swap them. So we always have a positive integer as an answer. I've seen students do this on a normal basis. Don't fall into that trap. A negative number is fine if the second number is larger than the first in a subtraction problem, unless the problem explicitly states to flip the numbers if the second is larger. Don't do it. Generate a negative number if that is the answer. We need to be highly mathematical. We can't be nervous about generating negative numbers.